Hi guys, today I want to talk about the limit comparison test, and I'm going to go over two more tests, which is a limit comparison and alternating series of tests today. And I really want to finish this packet by today. So from the Wednesday, I'm going to start reviewing the AB instead of BC. Okay, so the two more tests left over is this. One is the limit comparison. So what is the limit comparison? If A7 is greater than or equals 0, B7 is greater than or equals 0, and A7 or B7 is L, or flip it, equals L, where L is both finite and positive. Then two series, sigma notation and 1 to infinity A sub n and the sigma notation B sub n, either both converge or both diverge. Okay? So, so you might wonder, what is that? Okay, so first of all, we need to determine which one is A sub n and which one is a B sub n. So when you determine the A sub n and B sub n, A sub n should be the leading term of the top and bottom. So which means the A sub n will be 1 over 3n squared, right? Because the leading term of a denominator is a 3n squared, and the 1 is the leading term of the numerator. So this is my A sub n. And my B sub n will be my whole fraction. So this is my B sub n. So which is a 1 over 3n squared minus 4n plus 5. Everybody's okay? So now you can either take the limit as n approaching to infinity A sub n or B sub n, or B sub n or A sub n. So either way. So let me divide A sub n by B sub n. So now limit as n approaching to the infinity. A sub n, which is a 1 over 3n squared, divided by B sub n, or multiply by reciprocal of B sub n, which is a 3n squared minus 4n plus 5 over 1. Now, since this one is a limit, we can just reduce the leading term, which is a 3n squared divided by 3n squared, which is a 1, which is L. We know this one is a positive and finite number. So we satisfy the first conditions, right? Okay, if the L is a positive finite, then the series, this, A sub n. So sigma notation 1 over 3n squared. Since this one is a converge, this one guarantees that B sub n, sigma notation B sub n, which is a 1 over 3n squared minus 4n plus 5, this one is also converge. Because this is an A sub n, this one is converge, this one, which is B sub n, is also converge. So answer, converge. Okay, now let's try B. Now B, so now let me determine A sub n. A sub n is a what? The leading term, so which is a n to the 4 over 4n to the 5th. Reduce it, which is a 1 over 4n. Now B sub n is just the series itself, right? So which is n to the 4 plus 10 over 4n to the 5th minus n to the 3rd plus 7. Now limit as n approaching to the infinity A sub n over B sub n, which is a 1 over 4n divided by B sub n, or reciprocal of B sub n, which is a 4n 5th minus n to the 3rd plus 7 over n to the 4 plus 10. Anyway, since this one is the limit, the top we have a 4n to the 5th, the bottom we have 4 times n to the 4th. So which is a 4n to the 5th. So 4n to the 5th over 4n to the 5th, which is a 1 positive finite number. Okay, now then let's check the A sub n, which is a 1 over 4n. We know this one is a, if you get rid of 4, we know this one is 1 over n, which is a harmonic, right? So we know this one is a diverge. So A sub n is a diverge, so B sub n, which is a series itself, is a diverge. So n to the 4 plus 10 over 4n to the 5th minus n to the 3rd plus 7 is also diverge. So answer, diverge. Okay. Now let's take a look at this. Okay. So this one, You can use a direct comparison, right? Okay, so a sub n is a 1 over n to the third. B sub n is a 1 over n to the third minus 2, right? Now the limit as n approaching to infinity a sub n, 1 over n to the third, times the reciprocal n to the third minus 2 over 1, so which is 1, positive finite. Now sigma notation 1 over n to the third, now n to the third by the p-test, isn't it? So by p-test, p is a 3 greater than 1, so we know this one is a converge, right? Since a sub n is a converge, so b sub n is also what? A converge. This one is also a converge. Okay. Now let's try D. All right. Now D, so a sub n, reduce the leading term, which is 1 over root of 3n. B sub n is just series itself, 1 over root of 3n minus 2. So now the limit n approaching to the infinity, a sub n 1 over root of 3n divided by b sub n, or reciprocal of b sub n, 3n minus 2 over 1, reduce the leading term, which is a 1. Positive finite. Now sigma notation 1 over root of 3n. We know this one is a 1 over root of n. By the p-test, the p is a 1/2, right? So diverge. So we know this one is a diverge. So b sub n, which is 1 over root of 3n minus 2, also diverge.